Hi everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. And in this today's session, I'm going to start with the IGCSE curriculum, and I'm going to start with the subject physics. And this is from the ninth grade. This is for the ninth grade. Of course, for the textbook is for both ninth and the 10th grade. But this chapter is the very first chapter of the book, and it is named as the chapter is named as measurements. Okay, physical quantities and its measurements, right? So this is the chapter I'm going to start with today. So it is pertaining to IGCSE curriculum, and it is for the ninth grade students basically, right? And let us get started. Okay. So to start with the physics subject, and that too with the very first chapter. Okay. So we should know that this particular chapter will be talking about the backbone of the physics. Okay, so what are the prerequisite knowledge that one should have about physics? That is very important. So here we are going to study some basic elementary concepts of physics. Okay, so whenever you want to start studying physics, first you should start, or you should know, or you should have the knowledge of something called fundamental physical quantities and its units. Okay, so physics is nothing but it's a study of physical quantities, its measurement and all that. Okay, so any physical phenomenon will have some physical quantities involved in it, and physical quantities are quantities which are measurable, and it will have some units. Okay, so let us talk about some physical quantities and its units, right? Okay, so the fundamental physical quantities are length, mass, and time. These are the three fundamental physical quantities. Now, length can be measured in meter, it can be measured in centimeter, it can be measured in millimeter, decimeter, decameter, kilometer, miles, light year. So, see, there are so many ways in which the length can be measured. Okay. Now, these are known as the units. Length is the physical quantity, the fundamental physical quantity is length, and these are all the units of the length that can be used to measure the various length. Okay, meter, centimeter, etc. Right? Same way coming to mass. Mass is also a fundamental physical quantity. Mass is a fundamental physical quantity. Now to measure mass, okay, you are going to use terms or expression like kilogram, gram, okay, then milligram, decigram, decagram, quintal, ton, etc. Okay, so these are nothing but the units of the mass. So whatever terms are used to express the mass, a physical quantity, not only mass, any physical quantity, are known as the units. Okay, let us come to the third fundamental physical quantity, and that is time. Time is measured in seconds and in milliseconds. Okay, of course it can be measured in hours also, it can be measured in minutes also, but then the fundamental units are seconds or milliseconds. Is that clear? Okay, now I don't know why I've written here seconds two time. It should be seconds, minutes, and then milliseconds, right? So I'll just do that correction. Yeah, it should be seconds and then minutes, okay, and then hour. So all these are units, okay, and then you have milliseconds as well. Okay, so to start with, we have understood what are physical quantities. Some of the fundamental physical quantities, they are three, and the various units associated with these fundamental physical quantities. Okay, now let us get ahead and go into deep. Now there is something called kilo, K-I-L-O, kilo. Okay, now this kilo is nothing but expressed whenever you multiply something by 10 raised to 3, or in other words, you remember that 10 raised to 3 is read as kilo in physics. Okay, 10 raised to 3 is read as kilo. Now 10 raised to minus 3 it is read as milli. Okay, 10 raised to minus 3 is read as milli. Okay, 10 raised to minus 3 is nothing but 1 upon 10 raised to 3, isn't it? So this is milli, and centi is nothing but 10 raised to minus 2. Okay. So from here, you will come to know this kilo is 10 raised to 3, milli is 10 raised to minus 3, and centi is 10 raised to minus 2. Same way, deci will be 10 raised to minus 1, deca will be 10 raised to 1 or just 10, and micro will be 10 raised to minus 6, and nano will be 10 raised to minus 9. Now, these are the phrases used to express anything which is in terms of 10 raised to 3, 10 raised to minus 3, etc. Okay. So if you find anything like 10 raised to 3, you can use the word kilo. If you find anywhere like 10 raised to minus 3, you can use the word milli. If you find anywhere 10 raised to minus 2, you can use the word centi that way. Okay, that is one way of understanding this. So kilo, milli, centi, these are all nothing but the prefixes which can be attached in front of any unit. Suppose you are talking about meter. So you can talk something in kilometer, you can talk something in millimeter, you can talk something of centimeter, isn't it? Suppose you are talking about mass, so you can tell the mass as kilogram, okay, or milligram, or centigram you normally don't say, but milligram and kilogram you can use for this 10 raised to minus 3 and 10 raised to 3. Okay. Deci is 10 raised to minus 1, deca is 10 raised to 1, micro is 10 raised to minus 6, and nano is 10 raised to minus 9. See, as we proceed, we are going to come across all these things once again, okay, and there you will get the connection of these numbers, the 10 to the power something, that, and these words, okay, you will get the connection. Okay. Now, 1 dm. Now, dm means what? 1 dm is decimeter. Dm stands for decimeter. Okay. So, deci jo hai, this is the symbol for deci is D. Okay. Remember here. Okay. You should not get confused. Deci ka symbol is D. Deca ka symbol is Da. Okay. So, very close. So, don't get confused. Deci is D. Deca is Da. So when you say 1 dm, d means deci. So 1 dm means 1 decimeter. 1 decimeter. Now instead of deci, I am writing 10 raised to minus 1. See, now you will get the connection. Deci is written for 10 raised to minus 1, isn't it? So 1 decimeter is nothing but 10 raised to minus 1 meter. Okay. Or rather, 1 meter multiplied by 10 raised to minus 1 will give you 1 decimeter. Okay. Or you can straight away say 1 decimeter is equal to 10 raised to minus 1 meter. Okay. Now coming to centimeter, 1 centimeter. Centimeter, I told you, centimeter ka, here you have. The symbol is cm. Okay. And centimeter is used for 10 raised to minus 2. Okay. So 1 centimeter will be 10 raised to minus 2 meters. Okay. That way 1 millimeter. Now 1 millimeter, I told you, see, millimeter, the symbol is mm. So 1 millimeter is equal to 10 raised to minus 3 meter. Okay. So here in these three examples, 1, 2, and 3, the unit is meter, but meter is expressed in centimeter, in millimeter, in centimeter, and in decimeter, isn't it? You can use dm also, dam also. Now this 1 dam, this da is the unit for what? Deca. Okay. This da is the symbol. Deca ka symbol is da. So when you say 1 dam means decameter. Okay. Da means deca. Deca is nothing but 10. Okay. So 1 decameter will be 10 meter. Isn't it? 1 kilometer will be, kilo is used for what? It is used for 10 raised to 3. So you will get 10 raised to 3 meter. Kilometer. The symbol is km. Okay. And so here I'll write kilo, the symbol is km. Okay. Micro, the symbol is like this, mu, and nano, the symbol is n. Okay. Nano ke liye you can use n, right? Fine. If it is nanometer, you write nm. If it is micrometer, you can write mu m. Okay, that also you can do. Mu m. This is micrometer, isn't it? Fine. So these are the these are the units. Some are smaller units, some are bigger units. Okay. Bigger units than meter are kilometer. This one is bigger than meter, and this mile is also bigger than meter. And this decameter is also bigger than meter because it is 10 times meter. Okay. So these three units, these three, kilometer, decameter, and mile. Okay. These three units are bigger than meter. And these units, that is decimeter, and which one is there? Yeah, millimeter, micrometer, nanometer, millimeter, centimeter. All these are smaller units than meter. Okay. So try to understand. So meter is a unit in SI system. You'll come to know what is this SI system. Meter. So some units are bigger than meter, some are smaller than meter. So bigger than meter, okay, bigger than meter will be kilometer, decameter, mile. These are bigger units. Smaller units of meter will be centimeter, millimeter, isn't it? Decimeter, decimeter is written as dm, okay, and then micrometer and nanometer. These are smaller units, okay. So these are smaller units and these are bigger units. So you should know that there are certain units which are bigger and there are certain units which are smaller, okay. Now let us try to understand some numbers in indices form. Suppose you have a number like 4000. This 4000 can be expressed in mathematics as 4 into 10 raised to 3, okay. 4000 can be written as 4 into 10 raised to 3. Similarly, 400 can be written as 4 into 10 raised to 2 and 40 can be written as 4 into 10. Okay, so this is nothing but a little bit of mathematics, okay, which you should always, the mathematics and physics go hand in hand, okay. So you have to always associate mathematics and physics, okay. So wherever needed, you will have to learn something, some mathematics as well, okay, when you are doing your physics. Now 0.4 can be written as 4 upon 10. It can always be written as 4 upon 10 and 4 upon 10 can be written as 4 into 10 raised to minus 1. Okay. Same way 0.04 can be written as 4 upon 100 which can be in turn written as 4 into 10 raised to minus 2. So these index form may how to write the numbers that also you should understand very well. 0.004 will be 4 upon 1000 that is equal to 4 into 10 raised to minus 3. So if you are not good at this, then you should revisit your indices from the mathematics and you should make yourself perfect in these indices because these are the expression, these are the numbers in this form that you are going to use in physics now onwards, right? Chalo, let us proceed. There is something called standard notation or there's something called scientific notation, okay? Standard notation or scientific notation, right? What is the standard notation and scientific notation? Any number which is written in the form of a into 10 raised to n, a into 10 raised to n, such that a is between uh, 10 and 1, or you can say a is less than 10, okay, but you should write there also greater than 1, okay. So that I'll do here. A should be less than 10 and greater than 1, okay. A should be between 10 and 1, right? And this n, you know, this n should be a positive natural number, that is n should be greater than 0, okay, or you can say it should be a positive natural number. Of course natural numbers are positive only, so you can write that n is a natural number, right? Now if any number is expressed in this form such that a is between 1 and 10, then and n is a natural number, then this number is said to be in a scientific notation form. For example, 4 into 10 raised to 3, this is a number in scientific notation form. Why? Because 4 is nothing but a number between 1 and 10 and 3 is nothing but a positive integer, okay. So this 4 is nothing but the value of a and 3 is nothing but the value of n. So it is satisfying the definition which says that a should be between 1 and 10 and n should be a positive natural number or greater than 0. And because this is satisfying this condition, this is of course in the standard form, or you can say scientific notation form. Now suppose you have a number like this 9834000. Now it's a huge number, and now this is occupying a lot of space also, and it is very confusing also. So I'll do one thing, I'll write this number in the shorter form, in the scientific notation form. So what I'll do, you know, this 9834 first I'll write as 9834 into 10 raised to 3. See, this is 9834,000, right? So 9834 multiplied by 10 raised to 3, I'll write this way. Now, here I cannot say that it is in a scientific notation form. Why? Because this 9834 has to be between 1 and 10, isn't it? It should be greater than 1, less than 10. But this is greater than 10, 9834. So I'll have to do something about this. So what I'll do, you know, this 9834, I'm going to write as 9.834. Okay, what I'll do, 9834, I'm going to write as 9.834. Now, how I'll do that? 9834, if I want to bring this decimal point over here, okay, so what I'll do, I'll divide this number 9834 by 1000. But if I divide by 1000, I'll have to multiply also by 1000, okay. So this 9834 can be written as 9.834 upon 1000 into 1000. Okay, 9834 upon 1000 into 1000 will be 9.834, isn't it? Now what happens, this 9.834 can be written, this 9834 can be written as 9.834, but in doing so what is happening, you are dividing by 1000, so you have to multiply also by 1000. So when you divide by 1000, that denominator में जो 1000 है, that is used in bringing this decimal point over here, that is after 9. Okay, so 9.834 is done. But this 10 raised to 3, say you will have to multiply another 10 raised to 3. So that will make 10 raised to 3 into 10 raised to 3, which is 10 raised to 6. So your scientific notation mein your number becomes 9.834 into 10 raised to 6. Okay. So this is how any number, big or small, can be converted into a convenient form, which is known as a scientific notation form. These things are very important in physics. You should start learning them. Next is derived physical quantity. Now, you know that there are three fundamental physical quantities: length, mass, and time. Now, these are not the only physical quantities, there are many other physical quantities. So, those physical quantities are known as derived physical quantities. So, what are derived physical quantity? Derived physical quantities are physical quantities which are made by using the fundamental physical quantities. For example, area. Area is used, the area is a unit which is made by multiplying the, or area is a physical quantity which is obtained by taking length two times, okay, multiplying length two times, okay, length time length, okay. And that is why, in the unit of area you will always find centimeter square, meter square, millimeter square, isn't it? So area is always a length multiplied by length, okay. So area is a physical quantity which is a derived physical quantity. Why? Because it is obtained from the fundamental physical quantity length, but it is obtained by multiplying two times length, okay. So length into breadth. Breadth is also measured in breadth is also the unit of length only. Okay. So length and breadth can be taken as the unit of length only. So meter square, centimeter square, millimeter square, kilometer square, acre, all these are nothing but the units of area. So area is a derived physical quantity. Same way, volume is another derived physical quantity. Now, volume of a cubical object is length into breadth into height. Okay. So, volume, and if it's a cylindrical shape, then also you have a formula for that. But volume is something which will be given by length into breadth into height. Okay. Now, in this case, length, breadth, and height, all three are nothing but the physical quantity length which has been used. But here you are using the length three times. Okay. For example, length in meter, then breadth in meter, then height is also in meter. Okay. So meter into meter into meter will be meter cube. If you are taking in centimeter, it will be centimeter cube. Millimeter, millimeter cube. So volume ka unit happens to be meter cube, centimeter cube, millimeter cube, kilometer cube, or liter also. Okay. So these are the units of volume. Volume and area both are derived physical quantities. Getting it? Okay. Acre, then hectare is also a unit for area. Okay. Fine. Now coming to some basic relationship between these units. Okay. Now what is the relationship? Now this, this you should become like, it should be on your fingertips. Okay. Now this is very easy once you have digested everything. Okay. Then you can play with these units. Now in physics, lot many times you will be required to convert one unit into another unit. Okay. So you will be required to convert meters into centimeter, or centimeter into millimeter, kilogram into gram, or kilogram into milligram. So you will be always confronting this type of problems where you will have to change the unit. Conversion is a part of a game in physics. Okay, everywhere conversion will be required. So how to convert these units, that is from one form to another form. Okay, how to convert the units, that is very very tricky, and once you understand, then it becomes very easy. Okay, so slowly steadily I'm going to make you understand how it works. Conversion. Now suppose you want to convert 1 millimeter square, okay, into say centimeter square. Okay, I'm concentrate here. millimeter square to centimeter square. Okay, suppose they have told you that uh, uh, a cell or a body is having an area of 5 millimeter square. Okay, there is some body, you can say some insect. Okay, its body surface area is 5 millimeter square, but for some reason, I want this particular area in centimeter square. Okay, this is where conversion comes in picture, isn't it? So I want to convert millimeter square into centimeter square. Now millimeter square and centimeter square both are the units of area, but millimeter square is a smaller unit than centimeter square. Millimeter square is a smaller unit than centimeter square. Okay. So anyway, if you want to convert millimeter square into centimeter square, then you will write here millimeter square into arrow mark centimeter square, right? Okay. Now what if you want to convert this, how you are going to start? How much millimeter square you want to convert into centimeter square? See, I want to convert 5 millimeter square into centimeter square, isn't it? 5 millimeter square into centimeter square. Now what I will do is I will write this as 5 into millimeter into millimeter. Okay, this 5 millimeter square I can write as 5 into millimeter, right? Then again, this I'm going to write as 5 into, now this millimeter I'm going to write in, convert and write it in centimeter. Now how you will do that conversion? Everybody knows that 10 millimeter makes 1 centimeter, or you can say 10 millimeter is 1 centimeter. So 1 millimeter will be how many centimeter? 1 millimeter will be how many centimeter? So you have to do cross multiplication. It will be 1 into 1, 1 upon 10. So it will be 0.1 centimeter. So for this, I will write 0.1 centimeter. And there is one more 0.1 centimeter. Got it? So my answer in centimeter square will be 5 into 0.1 into 0.1 centimeter square. Okay. Now for calculation, to make the calculation easy, I'll write this as 0.1, I'll write as 1 upon 10. This also I'll write as 1 upon 10. So unit will be centimeter square. Now 5 into 1 upon 10 into 1 upon 10 can be written as 5 upon 100. Okay. Which is nothing but equal to 0.05. So 0.05 centimeter square is my conversion value. Got it? So 5 millimeter square is nothing but 0.05 centimeter square. Okay. Now see here, I have started with millimeter square to centimeter square. 1 millimeter square is equal to 1 millimeter into 1 millimeter, correct? Now 1 millimeter I can replace into centimeter by writing 1 upon 10 centimeter. This 1 millimeter also I can write as 1 upon 10 centimeter. Now why I converted? Because I want in centimeter square, the area. So this happens to be 1 upon 100 centimeter square, isn't it? 1 upon 100 centimeter square. So I get 1 millimeter square is equal to 1 upon 100 means 10 raised to minus 2 centimeter square. But I want 5 millimeter square. Okay, 5 millimeter square equal to how much centimeter square? So now I'll multiply. So it will be 5 into 10 raised to minus 2 centimeter square. And 5 into 10 raised to minus 2 is nothing but 5 upon 10 raised to 2 centimeter square. And 5 upon 10 raised to 2 is nothing but 0.05 centimeter square. See, I got here also 0.05 centimeter. I got here also 0.05 centimeter. So this was just one example I explained you. I tried to explain you in detail. But now you should develop that habit and you should become perfect in this conversion. There are a lot many conversions. You can see the whole screen is full of conversions. Okay. But I'm not going to explain you each and every conversion. These remaining conversions you can do of your own. You can try of your own. But everything is there on the screen. So there won't be any doubt for you to get confused. Okay. But you have to practice and get yourself acquainted well with these conversions. Okay. Then only you can think of doing something in physics. Okay. Right. Now, these are how the conversion works. Now, in the practice session after this lecture, I'll give you a lot of conversions that you will have to work on. Right. Now, 1 acre. Now, what is this 1 acre? Acre, I told you, it is also a unit of what? It is a unit of area. 1 acre. 1 acre is something which is 100 meters square. Okay. So, what is 1 acre? 1 acre of land is equivalent to 100 meters square of land. Okay, so whatever is 100 meters square is known as 1 acre. Okay, what is 1 hectare? 1 hectare is uh, 1 hectare is I'm sorry, write that again for you. Uh, yeah, 1 hectare, HECTARE. 1 hectare is equal to, this is 10 raised to square, this will be 10 raised to 4, okay, meter square. So remember this relationship. 1 acre is 100 meters square and 1 hectare is 10,000 meters square, or you can say 10 raised to 4 meters square. Okay. Now these are something called standard relationship, and from this standard relationship you can always get the conversion value. Okay. So if somebody is asking you what will be 5 acre equivalent to in meter square, or if they ask you convert 5 acre into meter square, then what you will do, you are going to use this standard thing. Okay. Or if somebody asks you that a land is say 50,000 meters square, okay, the area is 50,000 meters square, so tell me the answer of this in hectare. So again you can use this particular relationship, the standard relationship. So standard relationships are very important, so that you should know, you should always not have any doubt about the standard relationships. Okay, so these are some standard relationships. So 1 acre is 10 raised to 2 meters square or 100 meters square. 1 hectare is 10 raised to 4 meters square. These are all known as standard relationships. Okay. Now, if you go on interconnecting them, you will get all these other relationships also. Okay. So 1 acre is 10 raised to 2 meters square, that is 100 meters square. 1 hectare is 10 raised to 4 meters square. These are standard. 1 hectare can also be written as 100 acre. Now here you get a new relationship between hectare and acre. Okay. So from this two standard relationship, you will get 1 hectare is equal to 100 acre. 1 hectare is equal to 10 is to 2 acre also you can write. Okay. So 1 acre means 10 is to 2 meters square. 1 hectare means 10 is to 4 meters square. 1 kilometer square is 10 is to 6 meters square. Remember that. 1 centimeter square is 10 is to minus 4 meters square, and 1 millimeter square is 10 is to minus 6 meters square. Okay, you need not by heart all this relationship, no, not at all, but you should know how to work and how to work on it and how to get it whenever required. Okay, so this by practice definitely you will get it. So till now I have explained you the physical quantities. I started with fundamental physical quantities, I came to derived physical quantities. In derived physical quantities I explained you till now about the area. Okay, now this volume part. Okay, now this second derived quantity is volume. This volume part we will be discussing in the next video, and till then I will try to wind up this session here only. And if you happen to like my videos, okay, please subscribe my channel, and that will motivate me to make more videos. I am a bit slow, I am going in details, but I see to it that people over there are getting everything in detail. Okay, I'm not in a hurry, I'm not, I don't rush topic wise. Okay, I go and try to make the concepts very clear for the students over there. Okay, and that is why I go piecewise, right? So till now I have explained you only till the area part of the derived quantity. In next video I'll start with volume and we'll proceed with the other things also. So till then, goodbye, take care all of you, bye bye.